Hello everyone. This video will cover elaborate analysis of Kristin's Cookie Company case study. So we are going to start with a process flowchart. It shows that it shows journey of 1 dozen cookies. It starts with a receiving order, clean and mix. That takes 6 minutes per order. Then spoon, 2 minutes per dozen. These two are done by Kristin. Setting up the oven. This is done by friend, but the oven is also involved in that. And then I have a oven baking for 9 minutes, cooling for 5 minutes. That is done by air. Packing and payment. Packing is 2 minutes per dozen, and payment is 1 minute per order, both done by friend. Very first question that we are going to answer is how long will it take to prepare 1 dozen rush order? That is just add up all of those numbers. One common mistake is double counting this one here. From customer's point of view, this is just 1 minute. Doesn't matter how many resources are involved in that one step. All right, so that's going to bring us to 26 minutes. We are going to call that flow time. That's how long it takes for 1 dozen of cookies for one customer to go from one side of the process to the other side. That is how long it takes to take the input and turn it into output. Uh, Next question we are going to answer is how many 1 dozen cookies can we process if we operate only 4 hours per night? One, understandably, one of the first solutions that come to mind is, well, if you operate 4 hours a day, then I'm gonna have 240 minutes. If every product takes 26 minutes to produce, then 240 divided by 26, that's going to give me roughly about 9 orders. This is a wrong solution because it ignores the fact that resources can work at the same time, meaning while oven is baking uh, the dozen number 2, Kristin can start preparing dozen number 3. All right, so that this solution ignores that. In order to answer that question, we are going to first talk about concept of capacity. Capacity is a maximum, a unit, a person can produce, can deliver in just 1 hour or in one shift. All right. How do we find capacity? We are gonna find capacity for resources. First, we are gonna look at resources that we have: Kristin, friend, and oven. I understand that you might list even more resources, trays, or you might list um, mixer, and there's nothing wrong with that. Once you do that, you are going to realize that, you know what, in no part of in our analysis they are going to be a limiting factor. So that's why I've removed them from here. Next, we are going to look at how long it takes, independent of other resources. How long does it take for Kristin to handle 1 dozen cookies? And that's going to be 6 plus 2, 8 minutes. Then again, independent of other resources that we have, in 1 hour, how many orders can Kristin handle? Which each order I assume is equal to 1 dozen. That's going to be 60 divided by 8, which is 7.5. I'm going to repeat that for all of these resources. And the resource with minimum capacity is, we are going to call that bottleneck. Bottleneck is the resource with minimum capacity. Why concept of bottleneck is important? Because capacity of a process is equal to capacity of its bottleneck. In this case, my bottleneck is oven, so capacity of my process is going to be equal to 6 dozens per hour. What does that mean? Because if you look at the first hour, you are not going to produce 6 dozens in 1 hour. This is what it means. Sometimes processes like this one, they need some sort of a warm up, or they might even need some sort of a cool down and cleaning at the end. If you look at the first hour will not deliver 6 dozens per hour. If you look at the last hour, most likely it is not going to deliver exactly 6 dozens per hour. It's going to be less than that. When we talk about concept of capacity, we are talking about the steady state, meaning if I ignore the initial warm up period, if I ignore the last cool down period, somewhere in the middle, when process is up and running, in 1 hour, how many on average can this process produce? That is going to be on average, it's going to be 6 dozens per hour. And another related concept is concept of flow rate. Flow rate, another name for it is actual output rate. Actual output, let me put it right here, output rate. Capacity is the maximum. Capacity is the maximum a process can handle. Output rate or actual output rate or flow rate is the number of units, number of dozens of cookies, number of cups of coffee that the process actually delivers. If a process has capacity of 6 and demand for it is way less than 6, the actual output is not going to be 6. It's going to be whatever customer wants, all right? So in a lot of practical situations, flow rate is going to be strictly less than capacity. In this note, in this video, for the sake of argument, for sake of for learning purpose, what we are going to do, we are going to assume that um, there is plenty of demand for product of this process. All right, now let's go back to that earlier question that we had. Finally, how many 1 dozen cookies can we handle in 4 hours? In order to answer that question, one of the best tools for showing some important concepts is Gantt chart. What I'm going to do, I'm going to just follow again 1 dozen cookies on journey, but in a slightly different format. I have resources written on a y-axis and I have time on x-axis. Kristin starts at time 0, very first dozen of cookies for 6 minutes, and then Kristin spends 2 minutes for spooning, 1 minute roommate for setting up the oven after that, then 9 minutes of baking, 5 minutes of wait, 2 minutes of pack, and 1 minute of payment. This is where the very first product comes out. 1 dozen cookie come out. How about the second one? Second one I've shown with the red ink because oven is going to be busy until this time, which I believe is minute 18. Even if I start second dozen, if Kristin starts second dozen at minute 8, exactly at minute 8, it's going to finish at minute 16. There's going to be 2 minutes of idle time there. Rather than doing that, this time I have decided to take that 2 minutes of 2 minutes of break, 2 minutes of idle time between 2 dozens. That's why you see these 2 minutes of break, all right? Later on, for dozen number 3, I have decided to start it immediately after finishing dozen number 2. It's up to you, all right? So let's talk about the red one. Again, 6 minutes of preparation, 2 minutes of spooning, 1 minute of exactly at that time oven becomes available, 1 minute of setting up oven, 9 minutes of baking, 5 minutes of dry time, cooling time, 2 minutes of pack, and 1 minute of payment. Second order comes out, or second dozen comes out at minute 36. The time interval of 10 minutes is not coincidence that it's 10 minutes is the time at the bottleneck as well. All right, that 10 minute is dictated by the bottleneck, and that 10 minute we are going to call that cycle time or takt time or kachang time. If you do, and for the sake of keeping this video as short as possible, I'm not going to follow the third order, but if you follow the third order, you are going to see that the third order comes out at minute 46, and that 10 minutes, every 10 minutes, process repeats itself. All right, with that in mind, now let's see how we can calculate cycle time before answering that question that I've asked you like 5 minutes ago. Cycle time, we saw that we can, in this case, is 10 minutes, and we answered and we found it using a Gantt chart. However, that is not the best way to find cycle time. Cycle time is much easier to find it simply by this. Cycle time is equal to 1 over flow rate. And if I consider that this process works at full capacity, then my flow rate is going to be equal to my capacity, which is 6 dozens per hour. In that case, my cycle time is going to be 1 over 6 hours per dozen, and that brings me to 10 minutes per dozen. All right, so you see that cycle time, either you finding it from Gantt chart or finding it with this way, it's 10 minutes, but it's best and it's much faster, and it's much easier, and it's a lot more reliable to solve it using this method. All right. One last concept before answering that question. Direct labor content is another time metric that we have in process analysis, and that shows the amount of labor time that goes into production of one unit. In this case, it's 6 minutes plus 2 minutes of Kristin's time, 1 plus 2 plus 1 minute of friend's time or roommate's time. It's gonna bring me um, all the way to 12 minutes. All right, so direct labor content here is 12 minutes. Finally, let's answer that question. How many orders can we handle in 4 hours? It's going to be, first order is going to come out at minute 26, and after that, every cycle time, every 10 minutes, one order is going to be processed. So there is a nice order in this part, so I'm going to first take advantage of it. This time, length of time is 240 minus 26 for initial 26. That's going to bring me to 214 minutes. Every 10 minutes, you are producing one unit. So in this part, you are going to, from minute 26 on, you are going to produce 21.4 orders. You cannot sell 20.4 orders, so I'm going to round that down to 21. And I've produced one in the first 26 minutes. That's going to bring me all the way to 22 orders, right? And the big part of process analysis is how can I improve the process? How can I improve? Specifically, we are going to focus on improving capacity of the process. These are different suggestions that usually comes up in every class. Well, instead of 1 dozen, use have order size of 2 dozen. Make customers order in 2 dozens, or use a bigger oven, or use or buy a second oven, or pre-mix the dough. Let me go over these very quickly before focusing on just one of them. Specifically, I want to focus on the very last one, pre-mix the dough. You look and see which products are very popular, what combination is popular, and make sure that that one is available in advance. Well, that is a great idea. That might reduce your flow time, but that is not going to improve capacity of the process, because your bottleneck is still the oven, and pre-mixing dough that happens before oven still has to go through oven. That is not going to improve capacity of the process. Again, it might improve your flow time, all right? But if you really want to improve your flow rate, actual output rate, you might be able to start a little bit early, work more than 4 hours, and actually bake those popular cookies and have them in stock. But that also goes a little bit against your business model of freshly baked cookies, but then that's up to you. So these kind of decisions, when you come up with these decisions, I want to be careful that whatever does not impact capacity of your current bottleneck is not going to improve capacity of your process. So with that in mind, um, let's talk about two important suggestions. One suggestion was, well, why don't you, instead of 1 dozen, use 2 dozens? That's a good idea. Let's see how that impacts our process capacity. I have 3 resources listed here. I have 1 oven, and each order I force customers to order 2 dozens. All right. Then time per order for Kristin is going to be 10 minutes. Capacity is going to be 6 orders per hour, and that is going to bring me to 12 dozens per hour. Right? Why 12 dozen? Because every order is equal to 2 dozens. It's the same story with friend. That's going to change my capacity to 17.14. But for oven, for every order, I'm going to spend 20 minutes. And that is going to bring my capacity to 3 orders per hour, which is equal to 6 dozens per hour. Still, my bottleneck is the oven. Still, capacity of bottleneck didn't change. As a result, your process capacity is not going to change. All right. This is a Gantt chart that I usually don't have time to draw it in class. I want to explain it here because it can be a little bit confusing. When you have 1 oven and your order size is equal to 2 dozen, then Kristin first is going to take care of 2 dozens, right? 6 minutes of 6 minutes of mixing dough, and then 2 minutes of spooning. The moment that spooning is done, is going to pass it to a friend to set up the oven, and 9 minutes of baking. While that is happening, Kristen is going to take care of spooning the second dozen of the first order. Then that one has to wait until oven is done with the very first dozen, and that is this moment right here, all right. That's when friend is going to take care of setting up the oven again for the second dozen of the first order, baking that, and um, in the 5 minutes of, once this one is done, 5 minutes of cooling for the second dozen of first order, 2 minutes of packing for that, and that one payment one time happens for the first dozen and second dozen. That is one time payment. All right, that is a common mistake by students, that they put uh, payment here as well. I think last night when I was recording this, I made that mistake on myself. So let's go to the next one. You're going to follow the same logic, and you're going to see that first order comes out at minute 36 and second order comes out at minute 56. Well, where is that cycle time of 10 minutes? Well, cycle time is going to be per order is going to be 20 minutes. And because every order is 2 dozens, your cycle time is going to be 10 minutes per 10 minutes per dozen. All right. Now, with that in mind, let's shift gears and talk about another concept called utilization. Utilization is the percentage of time that your resource is busy working. All right. Um, Assuming that we have only order sizes 1 dozen, and you only have one oven, let's find utilization. And if we assuming that process works at full capacity, meaning there's plenty of demand for it, Kristen's capacity is 7.5, Friend's capacity is 15, and Oven's capacity is 6. What is going to be the output of this process? Output of this process is going to be 6 dozens per hour. Kristen has capacity of 7.5, but Kristen is going to use only 6 of that. All right. So then utilization of Kristen is going to be 6 over 7.5. How about Friend? Same thing. Friend has capacity of 15, but because of limitations somewhere else in the process, Friend is going to use only 6 out of those 15 dozen capacities, and that is going to bring Kristen's capacity to 40. Oven's capacity utilization is going to be, I believe I said capacity, that is going to bring Friend's utilization to 40%. Oven's utilization is going to be 100%. All right. It's a bottleneck and it works at full capacity, so it's going to be utilized all the time. And if you look at your Gantt chart, you're going to see that bottleneck, except the first few minutes, that is a warm-up period, bottleneck all the time, which is oven here, works all the time. All right. Now, I'm going to, for the sake of keeping this video as short as possible, I'm going to look at another improvement suggestion, which is let's buy another exactly identical oven. What happens when you buy another identical oven? Let's look at process analysis for that. Let's see how much capacity improves, because at the end of the day, you want to answer this question: is it worth buying this oven? All right. If I buy one more oven, then this is the setup I have. Every order is equal to 1 dozen, and I have 2 ovens. All right. Kristen is gonna spend 8 minutes per dozen. Friend is gonna spend 4 minutes per dozen, and oven every order is going to, which is 1 dozen, is going to go through only one of these ovens. All right. You are not gonna bake it in 2 ovens, one oven after another one. So that's why time of every dozen in oven is 10 minutes. Right here, 10 minutes. All right. Now let's find capacities. Capacity of Kristen is 7.5. And 15 for Friend, and for oven, for each of those ovens capacity is 6, but because I have 2 of them, capacity of ovens are going to be 12. There you go, your bottleneck shifted from ovens, and now you have a new bottleneck called Kristen with capacity of 7.5. Even though you doubled the capacity of the older bottleneck, now the capacity of process did not double, because you have a newer bottleneck called Kristen that is going to limit capacity of your process. New process capacity is equal to 7.5. Now let's combine those two together. Once I know that, okay, I can improve capacity of process with 2 ovens, and my bottleneck right now is Kristen, What if I change order size from 1 dozen to 2 dozens? If I do that, this is what's going to happen. Kristin is going to spend that. This column is time per order. And remember, my orders are 2 dozen. Kristin is going to spend 10 minutes per order. Friend is going to spend 2 minutes for setting up the oven for each 1 minute per dozen, and then 2 minutes for each of those dozens packing, and then one-time payment at the end. All right, that's going to bring me to 7. And the oven is going to spend 20 minutes per order, which is 2 dozens. Well, how about capacity? Capacity of Kristin is going to be 60 divided by 10, 6. But because this is 6 orders per hour, because every order is equal to 2 dozen, that's going to be 12 dozens per hour, right? So capacity of Kristin improved. Friend's capacity, same story, is going to be 17.14, and oven's capacity is going to be, this one can be confusing. Capacity of one oven is going to be 3 orders per hour, but every order is 2 dozen, so I'm going to multiply it by 2 and get 6 dozens per hour. How about the second oven? Well, I have a copy of first oven, so total capacity of ovens is going to be 12 dozens per hour. All right. Now, with that in mind, let's look and see where the bottleneck is. Well, bottlenecks are, now I have 2 bottlenecks. I have an oven and ovens and Kristin. Both of them are my bottlenecks. Right. If I want to improve capacity of this process now, I need to improve capacity of both of ovens and Kristin. Otherwise, this capacity is not going to go up. All right. As a practice, if you want to try to analyze this process when order size is 3 dozens and number of ovens is equal to 2, go ahead and do it. It's not terribly difficult. Finally, let's look at profit margins for this small business. If I assume that business owners are paid for only for direct labor content for the time that they work, then and assume that price is equal to $3 per dozen, material cost is given, and I just make that this one is given in your case. A labor cost, I assume that it is $10 per hour. If you want to try different number, be my guest. Go ahead. If I have an order size of 1 dozen, profit margin is going to be $3 of price that I charge minus material cost minus direct labor content times labor times wage. All right, that's going to bring my margin to 30 cents. How about when order size is equal to 2 dozens? When order size is equal to 2 dozens, margin is going to be equal to, well, I'm selling 2 dozens. I'm gonna collect $6 of revenue minus material cost doubles, and this is the direct labor content of 2 dozen. Let's see what it is. 6 minutes for mixing, 2 minutes, 2 minutes. These are for spooning. 1 minute, 1 minute. These are for setting up the oven. 2 minutes, 2 minutes. These are for packing first and second dozen, and 1 minute finally for payment. That is gonna bring my margin to $1.76 per order, which is 2 dozens. It means my profit margin per dozen is 88 cents, which is a much bigger than when order size is equal to 1 dozen. This very simple example shows the value of taking advantage of economy of scale. And this is why Costco is a very, very profitable company. There are fixed costs that if you make customers buy at a higher volume, those fixed costs are going to get distributed into larger pieces, and that is going to have a huge impact on your on your profit. Right? I hope this helps you.